Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Believe it or not, all the devices in a corporate setting aren't necessarily using Wi-Fi. I know that's hard to believe because we're so used to using Wi-Fi connectivity, but it's true. We have to be concerned with how everything is connected in our networks, which includes the overall design of how things work together in our network. So what's a network topology? Well, a network topology is the way that all the pieces of hardware connect to one another. We're going to cover the variety of network topologies that we previously used and what we use in today's environment. A bus topology used a single cable that connected all the computers in a straight line like a bus. These types of networks sent data through the bus, and they needed a termination at the ends of the cable to prevent the network from going down. Now, a ring topology connected all the computers on the network with a ring of cable, which made a circle shape. These networks sent data in a circle from one computer to the next in the same direction because the ring was connected completely to itself and it didn't need any kind of termination. Now, both of these types of networks worked, but one of the biggest issues was that if anywhere on the cable stopped working, the entire network went down. Star topologies, which we also called hub and spoke, used a central connection box for all the computers to connect to. Now, a big difference here is that every computer had a dedicated connection into that central box, so that meant the links were fault tolerant, and then if one went down, it didn't take down the entire network. Now, one of the big reasons why star networks weren't that successful was because they weren't inexpensive to transition to from either a bus or a ring topology. Network designers at one point actually discovered that they could modify these connection boxes in such a way that it included the bus and the ring topologies inside of the box. However, the actual topology was a star topology. This made the physical topology a star, but signaling technology was a bus or a ring. So we had either star ring or star bus topologies. Mesh topologies are used by wireless devices where every computer connects to every other computer via two or more routes. Some computers might have a route going through another member of that mesh network. Now, mesh networks have two types of topologies. We have partially meshed topology, where at least two machines have redundant connection, so every machine doesn't have to connect to every other machine. Then we have fully meshed topology, where every computer connects directly to every other computer. It's extremely important that you know about cabling, not only for the exam, but for your career. Now, the types of cables that you'll use are going to vary in technologies and capabilities, like speed, for example, so make sure that you pay attention here. The most common cabling that you'll find uses copper wires wrapped with some kind of protective sheathing. The two main types are coaxial and twisted pair. Coaxial cable has a central copper conductor wire with insulation around it, which is surrounded by a braided metal shield. It's called coaxial or coax because the center of the wire and the braided metal shield share a common axis or a center line. The idea is that the cable is shielded from electromagnetic interference, or EMI, from office lights, copy machines, or any other appliance that generates magnetic fields. BNC connectors are a bayonet-style connector that was popular to use in early bus topology networks. You probably have coaxial cable in your house connecting your cable modem to your internet service provider right now. If you have cable TV, then it's using coaxial cable too. These kinds of cables use an F connector or an F-type connector that screws on for a secure connection. Now, there's two primary types of coaxial cables that you'll probably see. RG59, which is typically used for cable television, and RG6, which is much more common because it's a thinner cable. Now, coaxial cables have a radio guide or an RG rating for a quick reference of the type of coaxial cable that it is, but the important measure that you need to know is the ohm rating, the OHM rating, which is basically a measure of resistance. Now, it means that how much that cable is actually resisting the flow of electricity. Both RG59 and RG6 cables are rated at 75 ohms. It's not uncommon to see coaxial cables use a splitter to connect multiple devices together, or to use a barrel connector if you need to extend the distance to your connection. And you can see some examples here on the screen. Twinaxial cable is a coaxial cable that contains two central copper conductors wrapped around a single shield. Now, that might be used for short fiber connections, typically within the same network rack because it's cheaper and we call this direct attached cable, or DAC. By far, the most common type of cabling that you're going to see in networks is twisted pairs. Now, twisted pair cables are a pair of cables that work together, either transmitting or receiving data, which reduces the amount of crosstalk or interference, and they're bundled together in a common jacket. The more twists per foot, the less crosstalk. Now, there's two types of twisted pair cabling that you need to know about: shielded twisted pair and unshielded twisted pair. Now, if we compare the two, shielded twisted pair, or STP, consists of twisted pairs of wires surrounded by shielding to protect them from electromagnetic interference. You don't need to know the specific types of STP, but if you're interested, there's 6 different types of shielded twisted pair based on which part gets shielding. And then we have unshielded twisted pair, or UTP, which consists of wires surrounded by a plastic jacket, which is only a protective skin and it doesn't block any kind of interference. That means you've got to be careful around lighting, motors, or anything else that's going to produce that kind of interference. Now, benefit of UTP is it's less expensive than STP for about the same performance. When it comes to twisted pair cabling, there's a variety of different types and capabilities that you can use. Typically, we refer to the CAT rating when we talk about the specific cables. You can see on the screen some of the cable types can get significant bandwidth speeds. Today, in most environments, you're going to see Cat 6 cabling, but if you go to older networks or networks that haven't been updated, you might see some of these older cable types. Now, special notes here are that TIA is the Telecommunications Industry Association, who looks at the standards like the CAT rating. CAT cables can use 100-meter length cables with 10, 100, or 1,000 base T networks. When we talk about 10 gig base T networks, though, Cat 6 is limited to 55 meters. Cat 6A cables can use 100-meter length cables up to 10 gig base T networks. And Cat 7A cables are theoretically able to support 40 gig per second at 50 meters and 100 gig per second at 15 meters. Ultimately, just know what kind of cabling you're working with, either by looking at the box that it came in, or usually it's printed on the cable itself. And I would also make sure that you remember a lot of this information in this chart for your exam. When it comes to the connector, these cables use RJ45 connectors, but outside of the exam, you might also hear it called 8P8C or 8-position 8-contact connectors. Now, fiber optic cable is different than other types of cable because it uses light instead of electricity. Two of the primary benefits of using fiber include that it's not vulnerable to electromagnetic interference, and the other one is that it allows you to cover longer distances for transmissions. Typically, copper cable is only going to allow you to do a few hundred meters, but with fiber, you can go up to tens of kilometers. Fiber cabling has 4 main components. It has the core, which is made up of glass fiber, the cladding, which makes the light reflect down the fiber, the buffer to give it strength, and the insulating jacket to protect everything. I would not be surprised on a certification exam talking about networking, especially cabling, if they give you a diagram like this and they're like, which part is this? Or what component is this arrow pointing to? So just make sure that you understand this diagram. Fiber cables are manufactured based on their diameters of core and cladding. For example, you might see some of the common numbers that we have on the screen here regarding cabling. Today, fiber is going to come with 2 cables paired together. We call this duplex fiber optic cabling, which allows 1 cable to send and 1 cable to receive. Do you remember when I said that fiber optic cables use light to transmit data? Well, there's 2 types of lights that are used for different types of fibers. First, fiber optic cables that use LEDs are known as multi-mode fiber, or MMF, and then fiber optic cables that use lasers are known as single-mode fiber, or SMF. A big benefit of single-mode fiber is that it prevents something called modal distortion, which means that signals are sent at the same time, but they don't arrive at the same time because the path they take is slightly different lengths. This also enables very high transfer rates over long distances. You can typically tell the type of fiber based on the color of the cable. So yellow is typically single-mode fiber, and multi-mode fiber for shorter runs is usually orange. There's a few other colors that are out there, but you probably aren't going to be tested on that. There's 4 different fiber connectors that you need to know about: ST, SC, LC, which stands for local connector and is the main one that we use on fiber today, and MTRJ, which stands for the mechanical transfer registered jack and is common with companies like Cisco. Now, LC and MTRJ are considered small form factor, or SFF, connectors and improved on ST and SC connectors, although you might see companies who make fiber equipment having different connectors. Another quick point that I want to make is that with fiber, you need the right connector, but you also have to have a connection point called the physical connector, or the PC. The main 2 that you need to know about are the ultra physical contact, or UPC connectors, and these are polished extensively for a superior finish to reduce signal loss. And then angular physical contact, or APC connectors, add an 8-degree angle to the curved end and they lower signal loss even further. So what about cabling and fires? Well, there's two types of fire ratings that you need to know when it comes to cables. PVC, or the polyvinyl chloride, which has no protection whatsoever, and then plenum, which creates less smoke and fumes if it's burned, but it is more expensive. Now, most city ordinances are going to require you to have plenum, so just do it. You might hear about riser rating cables that are used for vertical runs on cables between floors of buildings, but it provides less protection than plenum. Again, just use plenum. The Institute of Electrical and Electronics Engineers, IEEE, is responsible for a lot of the standards for networking. Specifically, the IEEE 802 defines frames, speeds, distances, and types of cables to use for networking. You can see a few of the groups on the screen, but keep in mind that there's a lot more. So IEEE 802.1, higher LAN protocols. We have IEEE 802.3 for Ethernet. We have IEEE 802.11 for wireless.